Python programmers will often suggest that there are many ways the language can be used to solve a particular problem, but that some are more appropriate than others. The best solutions are celebrated as idiomatic Python, and there are lots of great examples of this on Stack Overflow and websites. An idiomatic solution is often one which has both high performance and high readability, but this isn't necessarily true. A sort of sub-language within Python, Pandas has its own set of idioms. We've alluded to some of these already, such as using vectorization whenever possible and not using iterative loops if you don't need to. Several developers and users within the Pandas community have used the term Pandorable for these idioms, and I think it's a great term. So I wanted to share with you a couple of key features of how you can make your code Pandorable. The first of these is called method chaining. Now, we saw that previously you could chain Pandas calls together when you were querying data frames. For instance, if you wanted to select rows based on an index, like a county name, then you wanted to only project certain columns, like the total population, you could write a query like dflock sub Washtenaw sub total population. This is a form of chaining called chain indexing, and it's generally a bad practice because it's possible that Pandas could be returning a copy or a view of the data frame depending upon the underlying NumPy library. In his descriptions of idiomatic Pandas patterns, developer Tom Osberger described a rule of thumb for this. If you see back-to-back square brackets, then you should think carefully if you want to be doing chain indexing. And I think this is great as a sort of code smell or anti-pattern. Method chaining, though, a little bit different. The general idea behind method chaining is that every method on an object returns a reference to that object. The beauty of this is that you can condense many different operations on a data frame, for instance, into one line or at least one statement of code. Here's an example of two pieces of code in Pandas using our census data. The first is the Pandorable way to write the code with method chaining. In this code, there's no in-place flag being used, and you can see that we first run a where query, then a drop NA, then a set index, and then a rename. You might wonder why the whole statement is enclosed in parentheses, and that's just to make the statement more readable. In Python, if you begin with an open parentheses, you can span a statement over multiple lines, and things read a little bit nicer. The second example is a more traditional way of writing code. There's nothing wrong with this code in the functional sense. You might even be able to understand it better as a new person to the language. It's just not as Pandorable as the first example. Now, the key with any good idiom is to understand when it isn't helping you. In this case, you could actually time both methods and see that the latter method is faster. So this is a particular example of a classic time readability trade-off. You'll see lots of examples on Stack Overflow and in documentation of people using method chaining in their Pandas. And so I think being able to read and understand this syntax is really worth your time. Here's another Pandas idiom. Python has a wonderful function called map, which is sort of a basis for functional programming in the language. When you want to use map in Python, you pass it some function you want called and some iterable, like a list, that you want the function to be applied to. The results are that the function is called against each item in the list, and there's a resulting list of all of the evaluations of that function. Python has a similar function called applyMap. In applyMap, you provide some function which should operate on each cell of a data frame, and the return set is itself a data frame. Now, I think applyMap is fine, but I actually rarely use it. Instead, I find myself often wanting to map across all of the rows in a data frame, and Pandas has a function that I use heavily there called apply. Let's look at an example. Let's take our census data frame. In this data frame, we have 5 columns for population estimates, each column corresponding with 1 year of estimates. It's quite reasonable to want to create some new columns for minimum or maximum values, and the apply function is an easy way to do this. First, we need to write a function which takes in a particular row of data, finds the minimum and maximum values, and returns a new row of data. We'll call this function min-max. This is pretty straightforward. We can create some small slice of our row by projecting the population columns, then use the NumPy min and max functions and create a new series where the label values represent the new values we want to apply. Then we just need to call apply on the data frame. Apply takes the function and the axes on which to operate as parameters. Now, we have to be a bit careful. We've talked about axis 0 being the rows of the data frame in the past, but this parameter is really the parameter of the index to use. So to apply across all rows, you pass axis equal to 1. Of course, there's no need to limit yourself to returning a new series object. If you're doing this as part of data cleaning, you're likely to find yourself wanting to add new data to the existing data frame. In that case, you just take the row values and add in new columns indicating the max and minimum scores. This is a regular part of my workflow when bringing in data and building summary or descriptive statistics, and is often used heavily with the merging of data frames. Okay, this is all great, and apply is an extremely important tool in your toolkit, but this lecture wasn't really supposed to be about the new features of the API, but about making Pandorable code. The reason I introduced apply here is because you rarely see it used with large function definitions, like we did. Instead, you typically see it used with lambdas. Now, you'll recall from the first week of this course that knowing lambdas isn't a requirement of the course. But to get the most out of the discussions you'll see online, you're going to need to know how to at least read lambdas. Here's a one-line example of how you might calculate the max of the columns using the apply function. You can imagine how you might chain several apply calls with lambdas together to create a readable yet succinct data manipulation script. So there are a couple of Pandas idioms, but I think there's many more and I haven't talked about them here. So here's an unofficial assignment for you. Go look at some of the top-ranked questions on Pandas on Stack Overflow and look at how some of the more experienced authors answer those questions. Do you see any interesting patterns? Chime in on the course discussion forums and let's build some Pandorable documents together. Our next lecture is going to be on group functions, and I'll see you then.